All right, hello, math fans. Today what we're going to do is kind of build off a little bit of yesterday because the last day, or day one, was talking about complex numbers and doing some computations with complex numbers. Now we're actually going to be talking about polar, okay? And this is going to be polar form of complex numbers. All right, so we'll make a comparison between the two, between polar form and rectangular form in a second. But let's polar form is sometimes called trig form also. Okay, it's kind of one and the same. So if we look at our axis, we usually have our x and y axis. Well, now we're going to have, this is our real axis, and this is our imaginary axis. And this whole thing is called the complex plane. Okay, because it's a complex number. And right, and you have your a plus bi, a plus bi. And of course, that goes on the real axis, and that number goes on the imaginary axis. Okay, so pretty easy. Let's just make a quick sketch then. If I had you guys graph negative 3 plus 2i, that would be negative 3 on the real axis and up 2 on the imaginary axis, and that would be the graph. It's actually a vector. Okay, so it's not just a point, it's from the origin 0, 0 to that coordinate. And here's another example. If I graph 4, well, 4, it's 4 plus 0i. You don't write the 0i, but that means we just go like this. And here's that vector. And we can just do negative 3i, which is just right down here, this point here. And that's that vector. Okay, so that's pretty easy. Again, these are all vectors. If I want to find the resultant of 2 minus 3i and negative 3 minus I, basically what you're going to do is you're just going to add them like vectors. So it's 2 minus 3i plus negative 3 minus I. And that gives you 2 minus 3, negative 1. Negative 3i minus 1i is minus 4i. So that is the resultant. And if I would just make a quick sketch of that, we have 2 minus 3i. So I'm going to change the color here so you can see a little easier. And it's 2 and then minus 3i. So our vector is down here. Okay, and then negative 3 minus I. So it's negative 3 minus I is here. And my resultant, just to kind of show you, it's negative 1, negative 4i. So negative 1, negative 4i right there. That is my resultant vector. And you can see, if I drew the parallelogram here, right? There we go. That's the resultant vector of those the 2 minus 3i and the negative 3 minus I. All right, so let's talk about the relationships. Well, if I make a quick sketch again here, and you notice I'm making a lot of pictures. And I'll tell you, pictures are really important for this whole chapter. Okay, I'm gonna pretty much draw a picture almost for every problem to convert between polar and rectangular to polar, and there's a lot of pictures involved here. So if here's my vector and this is x plus yi. So that means this is my x value, this is my y value, and this is our r value. Remember from back in the day, it's the radius, and we're going to call that theta. So let's kind of make some relationships now between this. If I said cosine of theta, that's just our old ratio, x over r. So if I cross multiply, I get x equals r cosine of theta. And same thing, I've got sine of theta is equal to y over r. Cross multiply, y equals r sine of theta. And then of course we have, using Pythagorean theorem, r squared equals x squared plus y squared. And so I can just say r is equal to the square root of x squared plus y squared. And it's not really, it is plus or minus, but we don't have to worry really about the minus because the radius is going to be positive, right? Okay, and then of course we have tangent of theta, and we all know that's our friendly favorite animal, the ox, y over x. So that's a pretty key formula too. Okay, so with these pieces of information here, we have, let's look at this. This is rectangular form, and let's convert that into polar. And basically what polar uses is it uses r and theta. Those are the only two things you're going to see in polar. Okay, r and theta. So if I substitute that in there, x is equal to r cosine of theta. So r cosine of theta plus, and here's y. Y is r sine of theta. So it's, I'll put this in parentheses, r sine of theta times I. Alright, and then if I factor out an r, I get r cosine of theta plus I sine of theta. And that, math fans, is polar form of a complex number. Very important. I'm going to put a little star next to it because it's so important. Okay. Now, there's a little abbreviation that the book uses, and I will allow you to use. Instead of writing r cosine theta plus I sine of theta, you can write that as r cis. I call it cis. I'm not sure if anybody else does. R cis theta. And of course, that stands for r cosine imaginary sine of theta. Okay. Again, radius cosine imaginary sine of theta. So it's a cosine of theta and imaginary number or imaginary value times the sine of theta. All right, so let's do a problem here with that. The directions will be right 6, and I'm going to write it in abbreviated form already. 6 cis 135 in rectangular form. Okay, so I'm going to expand it here because I think it's a good thing. Cosine 135 plus I sine of 135. All right, and again, sketch a nice picture here. It's 135 degrees. You can use those formulas that I gave you, but you know what? I like drawing a picture as opposed to trying to remember. I don't know. It's easy to remember some of the formulas, like cosine of theta is equal to x over r, sine theta y over r. That's not bad. But I'm going to get a reference angle, 45 degrees, and I want to find the cosine of 135, which you all know is root 2 over 2. Since it's over here, with all students take calculus, it's negative root 2 over 2. And plus I, and then sine of 135, if sine of 45 is also root 2 over 2, sine's positive here, so it's positive root 2 over 2. I'm going to distribute that 6, so I get negative 6 root 2 over 2 plus 6i root 2 over 2. Simplify it, I get negative 3 root 2 plus 3I root 2. And there you go. That is rectangular form. Okay. Remember, polar has r and theta. Rectangular has it doesn't have r and theta in it. I guess we're just using x and y because it's x plus y I. I mean, you're not actually seeing the r and the theta and the x and the y, but like the original problem, 6 is your r, there's your angle, there's theta. Okay, we get done all the way to rectangular. Here's your y value, or your x value, and here's your y value. Okay, so that's the conversion between the two. I will usually ask for it in exact form. Okay, so you'll give it to me as negative 3 root 2 plus 3I root 2. Sometimes you can put the I after, so they put 3 root 2I. The reason I don't like to do that is because sometimes people get confused and they don't write, they write it like this, 3I, or 3 root 2I, and it looks like the I is under the radical. So I prefer it this way. Okay, so let's go the other way around here, and let us write the complex number into polar, and again that's trig form. Alright, so here's your example, 3 minus 3I. So we're going to make a quick sketch because we need to figure out r and theta. And once we have r and theta, we're good to go. So again, this is our real is 3 here, and our complex is negative 3. So here's our coordinate. There's our vector. And this is 3 and negative 3. And then, of course, being that both sides are 3, we know this is a 45-degree angle here. But it's always measured from, your angle is always measured from the positive x-axis. So really my theta is equal to 360 minus 45, or 315 degrees. And we can use Pythagorean theorem, or you can just know it's x and x root 2. So it's just going to be, this is going to be 3 root 2. And that's going to be your r, 3 root 2. Now if you didn't want to do it that way, you wanted to use Pythagorean theorem, you could say r squared equals 3 squared plus negative 3 squared. So r squared equals 9 plus 9. R squared equals 18. So r is equal to 3 root 2. However you want to do it, I personally think all of our, first of all of our answers are going to be, for converting, they're going to be 30, 60, 90 triangles, or 45, 45, 90. So it actually makes it pretty easy, and I think you guys are pretty smart to know if you see a 3 and a 3, or a 5 and a 5, it's going to be a 45 triangle. If you see something like 3 and 3 root 3, you know it's going to be a 30, 60, 90 triangle. So I think it's pretty easy then to figure out the other side and the angle. Okay. Well, we didn't finish it up yet here. So our angle, or our polar form, is going to be, here's r, so it's 3 root 2 cis 315 degrees. That's it. Once you have r and theta, you're done. 3 root 2 cis 315. Okay. One other thing too is I know I got that 315 degrees by recognizing that. Of course, you could have also said tangent of theta is equal to y over x, and you do the inverse tangent of y over x. So, and we use the positive values. This is kind of from last chapter. We use the positive values because that's going to give us our reference angle. And the inverse tangent of 3 over 3, as you know, is 1. Right? The tangent of what is, I'm sorry, is 45 degrees, because the tangent of 45 degrees is 1. And then because we know we're in the fourth quadrant, because it's 3, negative 3, you know it's going to be 360 minus 45, which is 315 degrees. Okay, so I showed you how to do it graphically. Personally, again, I think graphically is the best way to go. But you're more than welcome to use more algebraic methods too. Okay, let's try another problem. This is a pretty mellow problem. Write in polar form. And here it is, negative 3i. Well, the first thing we're going to do is we're going to sketch it. This is the imaginary, it's on the imaginary axis, so we're right here. Okay, and again, this is an easy one because there is no triangle involved. And basically what we do is we say, well, r is equal to 3, and theta is equal to, go all the way around here, and that's 270 degrees. Okay, that's pretty easy. Now, some of you might think, well, wait a second, isn't it negative? Well, this is the deal. R is going to be always positive. And basically what theta does is theta compensates for a negative R value. All right, so we don't have to worry. All you do is just look at the theta is 270 degrees, R is 3. So my answer for this one is 3 cis 270 degrees. That's it. It's pretty easy. Again, you could have done it more mathematically, more algebraically, and do this coordinate right here would be your x value would be 0 and your y value would be negative 3. And so it would be negative 3 squared plus 0 squared, the square root of that, and then we say r equals 3. And we do the inverse, or the tangent of theta is equal to y over x, so negative 3 over 0. Well, it's undefined, and where's it undefined? It's undefined either at 90 degrees or 270 degrees. In this case, where it's located, it would be 270 degrees. So, again, I think the picture is a lot easier, but it's your call. All right, so that's it for day 2. Just wanted to show you the relationship between rectangular and polar graphs of complex numbers. And this is really important, though. It's complex numbers. Because later on, we're going to actually just graph coordinates, polar coordinates and rectangular coordinates. These are actually complex numbers in polar form and rectangular form. All right, math fans, that's it. And we'll do day 3 in the next lesson. Goodbye. Have a nice day.